Welcome to the Division of Education, Innovation and Energy e-learning program. I am your maths lecturer for today, and today we shall be looking at the topic of integers. Under integers, our objectives are to 1. Define integers. 2. Perform addition and subtraction of integers. 3. Perform the multiplication and division of integers. 4. To do problems involving powers and exponents involving integers, and to be able to work problems involving integers where orders of operation is important, or you have multiple operations within those problems. So, firstly, what are integers? These are whole numbers or negative natural numbers. Now, I want you to recall what real numbers, natural numbers, and whole numbers are. Now, real numbers are any number that you may know. Now, in mathematics, we usually represent the set of real numbers by a capital R. So any maths text or any math software that you are utilizing, once we are referring to real numbers, and we usually refer to things utilizing symbols. Once we are referring to real numbers, you would see a capital R. That capital R usually represents the set of real numbers. These are any numbers that you know. Your natural numbers are basically your counting numbers. Initially, our primary need was to determine the quantity of how much of any substance we may have. How many persons are in a room, how many animals we may have on a farm. So our natural numbers was that number system that we utilize to determine those quantities, and these are counting numbers, 1, 2, 3, 4, and we go on. Our number system needed to be revised some to now speak to the fact that we may have nothing at all. So our number system was expanded to now include 0, and that number system was defined as the set of whole numbers. Again, the symbol that we utilize to represent natural numbers is N. The symbol we utilize to represent whole numbers is W. And for what we are to do today, our number system was again expanded to include the set of integers. Integers are your whole numbers and your negative natural numbers. That's your set of integers. Now on a number line, we can see our integers on a number line. The positive integers are to the right of 0. The negative integers are to the left of 0. And I know that you would have worked with a number line before involving whole numbers and natural numbers. And so you know that as we move to the right, our numbers are increasing. As we move to the left, our numbers are decreasing. What can we do with integers? We can do the basic operations in mathematics with integers. What are the basic operations in mathematics? These are addition, subtraction, multiplication, and division. The question is, how can we perform these operations utilizing integers? So let's first start with addition and subtraction of integers. Using the number line, if we are doing addition, then we need to move from wherever we are at to the right. Addition is going this way. If we are doing subtraction, we move to the left for addition and subtraction of integers on the number line. Let's see what that looks like. Look at this case. 3 plus 5. And I know you all know that 3 plus 5 is 8. But here, the 3 here, this 3 is positive 3. And it's positive 3 plus 5. So if I'm doing positive 3 plus 5 on my number line, this is 0. Numbers to the right of 0 are positive. Numbers to the left of 0 are negative. So I'm doing positive 3. Now please note that in terms of our integers, we usually do not put the signs of the numbers if they are positive. So here I'm saying 3. That 3 is positive 3. And positive 3, we are adding to positive 3, 5. But, so what we are going to do is that we're going to start at positive 3, and we are going to add 5. But I want you to notice that the operation in the middle of the sign is the sign, the operation in the middle of the number, is the sign of the number that comes after. So this here, 3 plus 5 is actually positive 3, positive 5. So on the number line, positive 3, positive 5, we are going to start at positive 3. And then we are going to add 5. So it's going to be 1. Remember, addition is going to the right. Subtraction is going to the left. So it's 1, 2, 3, 4, 5. Positive 3 plus 5 is going to give us 8. Or we can say positive 3, positive 5 is 8. But remember, we are doing integers, so the signs are important. So positive 3, positive 5 is positive 8. Let's look here again. What about this one? Negative 3 subtracted 5. For negative 3 subtracting 5, how do we work this? We start at negative 3. Start at negative 3. Start at negative 3. And we are going to subtract 5. Remember this, the operation in the middle of the numbers is the sign of the number that comes after. So this negative 3 subtract 5 is actually negative 3, negative 5. Negative 3, negative 5, or negative 3 subtract 5 is negative 3 start at negative 3. I am subtracting 5, so I'm going to the, this is right, so I'm going to the left. When I'm subtracting, I'm going to the left. So it's going to the left by 5. It's 1. It is 1, 2, 3, 4, 5. Negative 3 subtract 5, or negative 3, negative 5 is negative 8. Let's look at this one now. 3 minus 5. Again, there's no sign in front of the 3, so this 3 is positive 3. And it's positive 3 minus 5, but here again, the operation in the middle of the numbers is the sign of the number that comes after. So this here is positive 3, negative 5. For positive 3, negative 5, how do we work positive 3, negative 5? We start at positive 3. 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 And we are subtracting 5. Or it is positive 3, negative 5. So start at positive 3. To subtract, we go to the left. To add, we go to the right. So it's positive 3, I'm subtracting 5, so I'm going to the left 5. 1, 2, 3, 4, 5. Positive 3, negative 5, or positive 3, subtract 5 is negative 2. Look at this one now. What about negative 3 add 5? Negative 3 add 5, again, the operation in the middle of the numbers is the sign of the number that comes after it. So negative 3 plus 5 is actually negative 3, positive 5. And so we are going to, starting at negative 3, we are going to add 5. To add 5, if we are adding, we are moving to the right. If we are subtracting, we're moving to the left. So start at negative 3, and we move to the right by 5. 1, 2, 3, 4, 5. Negative 3, positive 5, or negative 3 plus 5 is going to give us 2. But again, we are doing integers. So we must put the sign. What is the sign? The sign is positive 2. Now, what if the numbers that we are working with are too big for us to take the time to draw a number line? What then do we do to work our integer problems? What we do is this, the rules. There are some rules. What are the rules? For the addition and subtraction of integers, it's important that we specify the rules and the operations that they're working with. I have heard many times persons say a negative and a negative is a positive. That may be true in some degree, but it's based on the operations that we're working with. If we are doing addition and subtraction, the rules that I want you to utilize are these. If the signs on the numbers are the same, we add the numbers and keep the sign. However, if the sign on the numbers are different, we subtract the smaller number from the bigger number and use the sign of the bigger number. Again, the rules are these. For the addition, you must specify the operation. You cannot give the rule without the operation. For the addition and subtraction of integers, if the signs and the numbers are the same, we add the numbers and keep the sign. If the sign and the numbers are different, we subtract the smaller number from the bigger number and use the sign of the bigger number. Let's see how that goes. Now again, recall that this 30 plus 5, the 30 here is positive 30. So it's positive 30 plus 5. Or, again, the sign in the middle indicates, or the operation in the middle of the numbers indicates the sign of the number that, or the digit that comes after it. So this here is positive 30, positive 5. The signs on our numbers are the same. So which of these rules are we going to use? We are going to use this rule. If the sign and the numbers are the same, we add the numbers. 30 plus 5. Add the numbers, signs are the same. 30 plus 5 is 35. That's right, 35. And we are to keep the sign. Keep which sign? The sign on both numbers are the same. We are keeping that sign. So it's positive 35. Look at this one. Negative 4 subtract 10. Negative 4 subtract 10. The sign on the 4 is negative. Recall that the operation between the two numbers is the sign that goes with the number that comes after. So this is negative 4, negative 10. Negative 4, negative 10 is going to be what? Which of these rules apply? Remember, in stating the rules, we must state the operation that goes with these rules. So we are saying for addition and subtraction, if the sign and the numbers are the same, we add the numbers and keep the sign. If the sign and the numbers are different, we subtract the smaller number from the bigger number and keep the sign of the bigger number. So in this case, what are the signs here? This first one, he's negative. The second one is negative because the operation in the middle of the two numbers tells us the sign of the number that comes after this operation. So the operation here is subtraction. This subtraction makes this 10 negative 10. So it's negative 4, negative 10. If the sign and the numbers are the same, the signs on these numbers are the same. So what do we do? Which rule applies? The first rule again applies. If the sign and the numbers are the same, we add the numbers and keep the sign. Adding these two numbers here, 4 and 10 is 14. Keep the sign. Both numbers are negative, we keep the negative sign. If the sign and the numbers are the same, we add the numbers and keep the sign. Look at this one here. 20 minus 5. Again, positive numbers are usually not written with their signs. So this 20 here is positive 20. This is positive 20. This subtraction sign is the sign in the middle of the two numbers. If that sign in the middle of that operation in the middle of the two numbers, that operation goes with the digit that comes after. So this here is positive 20, negative 5. Positive 20, negative 5. Which of these rules apply? If the signs are different, the signs are different. So this rule applies. If the signs are different, we subtract the smaller number from the bigger number and keep the sign or use the sign of the bigger number. So positive 20, negative 5, positive 20, negative 5. Subtract the numbers. That is going to give me 15. And we use the sign of the bigger number. What's the sign on the bigger number? He's positive. So it's positive 15. Look at this example here again. Negative 10 plus 7. Negative 10 plus 7. The sign on the 10 is negative. The operation between the two numbers is addition. This operation is going to be assigned to the digit that comes after. So it's negative 10, positive 7. If the sign and the numbers are different, which rule do we use? We subtract the numbers. What is 10 minus 7? Subtract the smaller from the bigger and use the sign of the bigger number. This here is going to be equal to negative 3. Negative 3. For the addition and subtraction of integers, we must remember the rules that if the signs are the same, we add the numbers and keep the sign. If the signs are different, We subtract the smaller number from the bigger number and carry the sign of the bigger number. Now, what about instances where we may have double signs? There's some integer problem with double signs. Now, here what the rules are. It's very important that we understand that mathematics as life is made up of simple rules. Once we adhere to these rules, we can never go wrong. In addition to, with mathematics as with life, it's all about practice. So ensure and practice the exercises that will be posted on our YouTube channel. Look down below for the links to those lessons. So, double signs. Once the signs are the same, we replace these signs with a positive sign if they are double signs. If the signs are different, we replace these signs with a negative sign. What exactly does that mean? Look here. So it is 7. The 7, there's no sign in front of the 7, so the 7 is positive 7, and it's plus positive 5. So what we really have here is a case of double signs. It is positive 7 plus positive 5. If the signs are the same, once we are working integer problems where they are double signs, if the signs are the same, which rule do we use? This rule. If the signs are the same, we replace the signs with a positive sign. Replace the sign with a positive sign. Yes? So it now becomes 7 plus 5 if the signs are the same. Remember, this 7 is positive 7. So it's positive 7, positive 5. We then have to go back and use that rule that we had from before when we are working addition and subtraction. The addition and subtraction rules are, if the signs and our numbers are the same, we add them and keep the sign. So here we are going to add 7 to 5, that is 12, and we keep the sign, it is positive 12. Please bear in mind that maths is not done in silos, it's not done separately. All branches of mathematics are usually related. So this integer branch of mathematics that we are doing, it can be seen in almost every other branch of mathematics. When we get on to algebra, you're going to see him in algebra. When we get on to matrices, he's there. Vectors, he is there. Almost every branch in mathematics, you are going to encounter integers. It's important that we understand integers before we do any other aspect of mathematics. Look at another example of double signs. Double signs. Here, again, if there's no sign in front of a number, that number is correct, is right. That number is positive. So this here is positive 3 minus negative 5. Positive 3 minus negative 5, we have double signs. If the signs and the numbers are the same, which rule do we utilize? If the signs and the numbers are the same, we replace it with a positive sign. Replace with a positive sign. So this therefore becomes 3 plus 5. Again, the 3 is positive. Positive 3 plus 5, or positive 3 positive 5, we have to go back to our rules for addition and subtraction. Can you recall those rules? The rules for addition and subtraction are these. If the signs and the numbers are the same, we add them and keep the sign. If the signs and the numbers are different, subtract smaller from bigger, carry sign of bigger. Positive 3 plus 5. Signs are the same, add and keep sign. So this is going to be positive 8. Look here at another example. Look at this example here. Again, this 7 is what? That's right, this 7 is positive 7. So it's positive 7 plus negative 5. The signs, double signs again, double signs, double signs. So we are saying that with our double signs, in some problems there are double signs. With our double signs, if the signs are the same, we replace with a positive sign, as you have seen here. However, if the signs are different, what do? We replace them with a negative sign if the signs are different. So this here becomes 7, positive 7 minus 5, or positive 7, negative 5. Recall that the operation in the middle is the sign that is assigned to the number that comes after it. So this is positive 7, negative 5. Signs are different. If the signs and our numbers are different, we subtract the smaller number from the bigger number and carry the sign of the bigger number. The smaller number here is 5, the bigger number here is 7. So this is going to be positive 2. So look at this example here. It is 3, but the 3, remember, there's no sign in front of the 3, so it's positive 3. And we are subtracting positive 5. Again, double signs. If the signs are the same, replace with a positive. If the signs are different, replace with a negative. So this double sign here has to be replaced with a negative sign. So it's positive 3, negative 5. Positive 3, negative 5. We now go back to those rules for addition and subtraction of integers. Those rules are, if the signs are the same, add the numbers and keep the sign. If the signs are different, subtract the smaller number from the bigger number and carry the sign of the bigger number. So here we subtract. And smaller number is 3. Subtract that from 5, we have 2. So that's 2. And we carry the sign of the bigger number, that is negative 2. Now, what about problems, and you would encounter them, what about problems where there are more than 2 integers in the problems? So far, we have been working problems with only 2 integers. But there are problems that would comprise or be made up of more than 2 integers in those problems. What do? There are 2 schools of thought that I would like to share. First school of thought is work 2 of the numbers at a time. So here, and we are working from left to right. So here, we are working. In this case, the problem is 2 plus positive 5 minus positive 3 plus 4 minus 10. Working 2 numbers at a time from left to right, we are going to work these 2 numbers first. 2 plus positive 5. Like signs are the same. Remember that rule from before. If signs are the same, replace with a positive sign. So it becomes positive 2 plus 5. And again, we have signs being the same here as well. Signs being the same, it's negative, positive 3. So it's going to be, signs are different, replaced with a negative sign. So this here becomes 2 plus 5 minus 3 plus 4 minus 10. We go and work again. Here, working these 2 numbers, that is going to be 2 plus 5 is 7. We write back everything else that comes after. Working 2 numbers again. 7 minus 3. 7 minus 3 is 4. Write back everything else that comes after. 4 plus 4 is 8. And write back everything else that comes after. 8 minus 10. 8 minus 10, remember that rule. 8 minus 10 is going to give me negative 2. Signs on the numbers are different. We subtract the smaller number from the bigger number and carry the sign of the bigger number. Or, what we can do, if we have more than 2 integers in a problem to work, what we can do is that we can group them together. So here, we have the same problem as before, and now what we are going to do is just to remove our double signs. So scan through the problem. If you see double signs, you utilize your double sign rules. What are your double sign rules? If the signs are the same, replace with a positive sign. If the signs are different, replace with a negative sign. So this here becomes 2 plus 5 minus 3 plus 4 minus 10. Now we shall group the numbers together, putting all positive numbers together and all negative numbers together. What are positive numbers here? The 2 is positive, the 5 is positive, the 4 is positive. So it becomes 2 plus 5 plus 4. What are our negative numbers? The 3 is negative, the 10 is negative. So it's going to be negative 3, negative 10. What we then do is that we work out all the positive numbers. What is 2 plus 5 plus 4? 2 plus 5 plus 4 is, that's right, 2 plus 5 plus 4 is 11. And what is negative 3, negative 10? Signs and numbers are the same. Add them and keep the sign. That is going to be negative 13. So it becomes positive 11 minus 13, or positive 11, negative 13. And what is that? Positive 11, negative 13, if the sign and the numbers are different, subtract the smaller number from the bigger number and carry the sign of the bigger number. Remember this. I want you to remember this. It's important that we remember this. That these rules that we have done thus far, these rules only apply to the addition and subtraction of numbers. We are going to show you shortly the rules for multiplication and division of numbers or integers. What are the rules for the addition and subtraction of our integers? Recap the rules here. If the signs are the same, add the integers and keep the sign. If the signs are different, subtract the smaller integer or the smaller number from the bigger number and carry the sign of the bigger number. Multiplication and division. So we have just looked at addition and subtraction. For multiplication and division, are the rules the same as those for addition and subtraction? And the answer is a resounding no. So when working problems involving integers, the first thing that you have to do is to determine if you're doing addition and subtraction or multiplication and division. If you are doing addition and subtraction, we just showed you what you had to do. However, if you are to do multiplication and division, this is what we do. For multiplication, our rules are these. First rule, if the signs and the numbers are the same, we multiply the digits and the answer is positive. Second rule, if the sign and the numbers are the same, we multiply the digits, but the answer is negative. So it says, one multiplying, if the signs are the same, multiply the digits, your answer is positive. If the signs are different, you multiply your digits and the answer is negative. Look here. Here we have 6 multiplied by positive 5. Please note that the 6 is positive 6. So it's positive 6 multiplied by positive 5. Which of these two rules will we utilize? If the signs are the same, we multiply the digits and answer is positive. So multiplying our digits here are 6 and 5. Multiplying these digits, 6 times 5 is, remember, in mathematics, another building block is multiplication. If you can't do multiplication, then you can't really do mathematics. So you need to learn your tables. Very important, learn your tables. 6 times 5, what is 6 times 5? 6 times 5 is 30. The signs are the same, we multiply, answer is going to be positive 30. That's right, my answer is positive 30. Look at this case here. Negative 6 multiplied by negative 5. Again, signs are the same. If the signs are the same, which rule do we utilize? If the signs are the same, we multiply and answer is positive. So here, this here is actually negative 6 multiplied by negative 5. Signs are the same. What do we do? Multiply. 6 times 5 is 30. And the answer is going to be positive. Positive 30. We're going down the road here. Look at this one. Positive 6 multiplied by negative 5. Why did I say positive 6? Again, there is no sign in front of the 6, so therefore that 6 is positive. So it's positive 6 multiplied by negative 5. Which of these two rules shall we utilize? That's right, it's this one. Signs are different. If signs are different and we are multiplying, multiply digits again. 6 times 5, 30. And the answer is negative. Correct is right. Look at this one. Negative 6 multiplied by positive 5. Negative 6 multiplied by positive 5. Signs are different. Which rule do we utilize? Of course, the second one. If the signs are different, we multiply the digits and the answer is negative. 6 times 5 is 30. It is going to be negative 30. This integers is really amazing. I just love working with integers, don't you? Let's go on here. So, more than 2 integers in a multiplication problem. Now, I want to give you one approach. This is my approach. When I'm working more than 2 integers in a multiplication problem, what do I do? There are several approaches out there. But this approach is this, that you start from the leftmost integer and multiply by the integer next to it. The product that you get from doing that, you then multiply the next integer and so on. So let's see how that works. Look here. Look at this one. Positive 6, remember no sign in front means it's positive. Positive 6 multiplied by negative 5 multiplied by negative 3. So we are going to multiply the positive 6 by the negative 5. 6 times 5 is 30. Remember the rules. If the signs are the same and we are multiplying, answer is positive. If the signs are different and we are multiplying, answer is negative. So here is positive 6, negative 5. That is going to give me negative 30. So it's negative 30. And I need to write back everything else that comes after it. So after the 6 times 5, what came after? It was multiplied by negative 3. Positive 6 times negative 5 is negative 30. Now we are multiplying by negative 3. So it's going to be negative 30 multiplied by negative 3. The signs are the same. Multiply, answer is positive. This thing is really nice. I'm enjoying those integers here. Look here, this is another example. And I have negative 2 multiplied by positive 5 multiplied by negative 1 multiplied by negative 1 multiplied by 2. What do we do? Again, what are the first two numbers? So it's negative 2 multiplied by positive 5. Signs are different. I'm multiplying. Answer is negative. Negative 10. And I then go, remember to write back everything else that comes after. So it's multiplied by negative 1 multiplied by negative 1 multiplied by 2. I then go and do the same thing again. It is negative 10 by negative 1. Negative 10 by negative 1 is negative 10 by negative 1. Signs are the same. I'm multiplying. It's positive 10. And then I write back everything else that comes after. I go and do the same thing again. It's positive 10 now by negative 1. Positive 10 by negative 1 is going to give me negative 10. Write back everything else that comes after. And then I now multiply negative 10 by positive 2. I get negative 20. This is really nice. I must say, maths is one of the most exciting subjects that you can ever meet. Look here, division of integers. How do we divide our integers? The rules for dividing integers are similar to the rules for multiplying our integers. What are these rules for multiplying our integers? If the signs and the numbers are the same, we multiply the digits and the answer is positive. If the signs and the numbers are different, we multiply and the answer is negative. These rules are the same for division. So instead of writing multiply here, what we are going to write is divide. Divide. So we are saying for division, the rules are if the signs and the numbers are the same, we divide and the answer is positive. If the signs are different, we divide and answer is negative. So I like to separate my rules into just basic two groups. The rules for addition and subtraction and the rules for multiplication and division. Because the rules are there about the same. So when I'm dividing, I just divide. If the signs are the same, answer is positive. If the signs are different, answer is negative. The same thing applies to multiplying. I multiply. If the signs are the same, answer is positive. If the signs are different, answer is negative. Let's see how that works. Look here. Here we have 6, which is positive 6, divided by positive 3. Now, positive 6 divided by positive 3, we can represent it like this. That is the same as saying positive 6 divided by positive 3. And according to the rule says if the signs are the same, we divide, answer is positive. So we divide here. What is 6 divided by 3? 6 divided by 3 is 2, and the answer is positive 2. Remember, in order for us to do any problems in mathematics, we must be able to do our multiplication. You need to learn your multiplication tables as often as possible. Ensure you know how to multiply your numbers. Look at this one. This here is positive 6 divided by negative 3. Positive 6 divided by negative 3, again, this can be represented like this. Positive 6 upon negative 3 is the same as positive 6 divided by negative 3. And which of these rules apply? The signs are different. If the signs are different, we divide, and our answer is, so dividing here, 6 divided by 3 is 2, and the signs are different, so my answer is negative. Look here. Negative 6 divided by positive 3. Signs are different again. Remember, this negative 6 divided by positive 3 can be represented in this format. So it's negative 6 all upon 3. And negative 6 divided by negative 3. Signs are different. My answer is going to be negative 2. Because 6 divided by 3 is 2. And the sign is going to be negative. Look here. What about this case? Negative 6 divided by negative 3. Signs are the same. If the signs are the same, we divide, answer is positive. Negative 6 divided by negative 3, it is negative 6 all upon negative 3, which is going to give me 6 divided by 3 is 2. Signs are the same, it is going to be positive 2. How are we looking? We're looking good. This maths thing is really nice. I love this maths thing. We love this maths thing. Look here, exponents and powers. If we have problems that involves exponents and powers, what are we to do? Now, when we say exponents or powers, what do we really mean? The exponent or the powers, they tell us the number of times a number must be multiplied by itself. What does that mean? Look here. 2 exponent, the exponent here is 3. We call the 2 the base. We're going to see that as we go along in algebra. So the 2 is the base, and the 3 is the exponent. This 3 tells us that that 2 has to be multiplied by itself 3 times. So it's going to be 2 to the power of 3 is 2 times 2 times 2, which is going to give me 2 times 2 is 4, 4 times 2 is 8. Or what about this one? Negative 5 to the power of 4. Negative 5 to the power of 4, this power here or exponent here tells me that I must multiply the negative 5 by itself 4 times. So it's going to be negative 5 by negative 5 by negative 5 by negative 5, which gives me negative 5 by negative 5. Signs are the same, multiplying. That is going to give me positive 25. That is going to give me positive 25. And then I multiplied that answer by this negative 5. That is going to give me positive 25 by negative 5 is going to give me negative 125. Negative 125 multiplied by negative 5 is positive 625. What do we do? So we have looked at addition, multiplication, subtraction, division, and powers with our integers. What do we do when we have different operations in our problem? Bingo, that's right, we do BODMAS. BODMAS. What is BODMAS? BODMAS. BODMAS is the system that we use to tell us the orders in which the operation should be performed when working problems with multiple operands. What does this BODMAS say is an acronym. That means for us in mathematics, the B stands for brackets. When working problems with multiple operations, we are to do brackets if brackets are there. If brackets are not there, then we move on to the other one. Then we do O. O, what does O stand for? O stands for orders. What are orders? Your orders are your roots and your powers. So if you have roots and powers in your problem, you are to do those right after you have worked out within your brackets. So inside of the brackets, we need to work out what's inside of the brackets. If there are no brackets, we then check to see if there are roots or powers. If there are roots or powers, we work the roots or the powers. The next letter in our acronym, D, stands for division, then multiplication, then addition, then subtraction. So we are to work these here in this order. So we first check if there are brackets, work out what's in the brackets first. If there are no brackets, then we don't have to study about that. We check to see if there are orders. What are your orders? Your orders here are your roots and your powers. If there are roots and powers, we work those roots and powers. If they are not, no brackets, no orders, we then check to see if there's division. If there's division, work your division. If there's no division, work your multiplication. If you have all of these, then this is the order that you must work them. So let's look at an example of BODMAS, evaluating the following. Here we have different operations, do we not? We have subtraction, we have multiplication, we have brackets, and we have within the brackets subtraction. So what do we do? First, according to BODMAS, is that we work out the brackets. In the brackets, it's positive 4, negative 6. Positive 4, negative 6. Signs are different. Subtract smaller number from bigger number. Carry sign of bigger number. Then we check here. What do I have here now in terms of my operations? So I've worked out my brackets. What do I have next? It's 7, positive 7, minus 3, multiplied by 2, multiplied by minus. And so we multiply. What is negative 2 multiplied by negative 3? Negative 2 multiplied by negative 3, that is going to give us positive 6. 7 plus 6 is going to give us 13. Look at this other example here. Again, here we have, it seems as if we have 3 brackets, do we? Now the thing about brackets is that when we speak to working out inside of the brackets, we are checking to see if we have more than 2 integers in those brackets. If we have 2 or more integers in those brackets, then yes, your brackets apply. But in some instances, we only utilize our brackets as a form of separation. So here, this brackets here only indicates that here's what this negative 2 is separate from that positive and it's being cubed. So it has to be multiplied by itself 3 times. So when we speak to brackets, here we are speaking to these here. These are our brackets that we need to check when working BODMAS. So working my brackets here. it is going to be 4 plus 7 is 11. This bracket is what? 1 minus 6 is minus 5. Remember to write back everything else. So this becomes now 11 multiplied by negative 3 plus negative 5 plus negative 2 cubed. What do we work next? According to BODMAS, the next thing that we work is the orders. The orders are your powers or your roots. We have powers here. Negative 2 cubed. Negative 2 cubed is negative 8. Write back everything else. Then look at our operations here. What are the operations that we have? We have multiplication, addition, addition. What do we do next? According to BODMAS, of these three operations, the one that we do next in the order of hierarchy of BODMAS, the one that we do next is multiplication. So it's 11 multiplied by negative 3. 11 multiplied by negative 3 is negative 33. Write back everything else. And we have now, what we have, some double signs. We need to work out those double signs. Working out these double signs, we have negative 33, negative 5, negative 8. Negative 33, negative 5, negative 8 gives us what? Negative 33, negative 5, negative 8 is negative 46. What are some everyday uses of integers? Usually you hear persons saying that mathematics is so abstract you can't relate it to daily life. That is not necessarily true. For example, integers. We utilize integers in measuring temperature. When we measure the temperature of hot water, it is positive something. When we measure the temperature of cold water or ice, it is usually negative something. So integers is utilized in measuring temperature. We also utilize integers as we speak to sea level, above sea level and below sea level. So for those of you who are looking to become pilots, geologists, or some navigating officer somewhere, you would need to utilize integers because we are going to look at above sea level is positive, below sea level is negative. Of course, the most important part where integers is utilized is money. Our financial calculations. How much money are you going to get as we go through your life, or as we go through interacting with other people? So money is another important aspect that integers is utilized. If you owe money, it's usually assigned a negative value. If you have money, unlike me, it is going to be assigned a positive value. So integers is very important to our everyday life. Please remember that maths is the most exciting subject that you can ever meet. And for me, maths is mistakes. You are going to make mistakes from time to time. That's okay. Along the way to getting success, you are going to make mistakes. It's mistakes that allow thinking. Mistakes that allow thinking to happen. Without making these mistakes, most likely the level of thinking that you need would never occur. So please do maths, make your mistakes, and make informed mistakes. Think before you make your attempts. See you at the next class when we look at algebra. And we have come to the end of our lecture, so do enjoy.